Imagine a photocopier making a copy of a copy over and over again. Eventually, the crisp image degrades into unintelligible noise. This paper asks a critical question for the future of AI. Does the same thing happen when language models are trained on their own output? The researchers identify a phenomenon they call model collapse. As models enter a recursive training loop, training on data generated by their predecessors, they begin to lose diversity, forgetting the nuance and rare events that define human language. This degradation is driven by statistical approximation errors, essentially caused by training on a finite number of samples. Over time, the probability distribution narrows until it converges to what is called a Dirac mass, where the model predicts a single output with near 100% certainty. The authors analyzed two distinct paths using a simplified statistical framework. In a fully synthetic loop, they prove that total collapse is inevitable. However, a partially synthetic loop that mixes in real human data offers a path to stability. This figure illustrates the grim mathematical reality of the fully synthetic scenario. The bottom chart tracks how many generations it takes for a model to break down completely, showing that while increasing the sample size can delay the collapse, it cannot prevent the eventual loss of all diversity. While stability is possible in the mixed scenario, the requirements are steep. The author's Theorem 3 demonstrates that to keep the model close to the original distribution, the amount of synthetic training data must be significantly, identifiably exponentially, smaller than the volume of real data. To validate their theory, the researchers ran experiments using a GPT-2 model trained on the tiny Shakespeare dataset. The results confirmed the math. Pure synthetic loops caused a rapid spike in errors, while strategies like mixing in data from all past generations helped plateau the degradation. The implication is clear: the future of AI cannot rely solely on scraping an AI-filled web without careful curation. To maintain intelligence, we must actively preserve and prioritize human-generated data.